In this video, I'll show you a few tricks for saving, backing up, and recovering damaged files. Let's go ahead and open a few files to get started here. Go up to the Open icon on the Quick Access toolbar and navigate to the Chapter 2 folder. Let's open Plumbing, Mechanical, and the Architectural Imperial Units drawing file. So to select them, I'm going to hold down the Control key and select those three items. Click Open, and they will appear here on different file tabs. You can take a look. Let's say I made a change to one of these files. For example, here I could erase. I'll click the Erase icon here, and I'll erase this chair. I'll click on it and press Enter. Now I'd like to save the drawing. I could click on this icon, and that would save it with the same name that it has now. Or I could click on this one to give it a new name. I'll choose Save As, and I'll call it 2 on the end of the file name like that. Save. Now, if I make another change, say I pan the drawing by holding down the mouse wheel and dragging, you'll see that a little asterisk appears after the file name to indicate that the file has changed. You could now save it. I could either click this icon up here to do that, or type QSave, or the keyboard shortcut QS. Also, you can press Control S, so there's many different ways to do this. My favorite is just to type QS and press the spacebar with my thumb. That seems to be the fastest for me. AutoCAD will also automatically save the file after a few minutes, and you can control how long that is in the options. So let's go to the Application menu and click on Options and take a look at that. Under Open and Save, right down here you can choose to automatically save a copy of your drawing every 10 minutes or however many minutes you want. I find this to be a little bit disruptive because I can be working and then all of a sudden AutoCAD will pause for a second while it's saving a large file. I find this to be a little bit annoying, so I usually turn this off. But alternatively, you could increase the save interval to something like every half an hour, and maybe it wouldn't get in your way as much. You can also optionally create a backup copy of every file, and I have that on. So let me show you what happens when I save this. I'm going to press Control S to save, and I'll go over to the Windows Explorer, take a look at the file system here, and see what's happened on disk. So I have a new file, Architectural Imperial Units 2, that was created when I used Save As, and then the backup file was generated when I just typed QS. If you need to use this file, let's say this one gets corrupted or deleted, you just have to rename the file extension to DWG, and it will open as a regular drawing. This can be handy because you're doubly protected, but it takes up twice as much space on disk. So for that reason, I tend not to use this method. So if you don't want to automatically create a backup, you can go back to Options, and you can do that quickly by typing OP, Enter, and it will just turn off the backup file creation and the autosave feature. Of course, then you're running the risk of losing everything, but we still have yet another form of backup available to us through Autodesk 360. But that's only available if you sign in up here to the service. And then every time you save, a copy will be uploaded to the cloud. In some cases, you might need to recover a damaged drawing. There's a special command for that called recover. I'm going to type that in. Recover. Enter, and I will select this damaged drawing file, Open. It's taking a while to think about this and to analyze all of the objects in the drawing, and now it's found 2 errors. Who knows what they were, but thankfully they were fixed, so I can say close. If you experience some strange behavior in the program where a line, you know it exists but it doesn't show up, for example, you can try recovering the file, and it might correct any error. Now this is rare. This only happens in big project files that take a lot of memory. So I just want to point this out so you have another technique to save your data. In the next video, you'll learn how to set the drawing units. In this video, I'll discuss units. One of the first things that you want to do before you get started drawing is select a system of units. Open the Architectural Imperial Units sample file from the Chapter 2 folder, and then type UN Enter for units. This drawing is currently set to architectural, which means the foot and inch system. The symbol of inches is the double quote here. the symbol for feet is this single quote. They're both on the same key next to the Enter key on the keyboard. You don't actually have to ever type in the inch symbol, because AutoCAD is going to interpret a number like 18 as 18 inches. You could alternatively enter that as 1 foot 6. That's one single quote 6, and AutoCAD will interpret that as 18 inches, just the same. You also have these other choices for units. So let's say I was using the metric system. I would select decimal units in that case. Engineering units are actually based on feet and inches, but they use decimals. So if I wanted to say 18 inches in engineering units, I would say 1.5 feet. Fractional units are inches only, no feet, and these are used by cabinet makers, for example. Instead of saying 5 feet, they would just say 60. Scientific units have exponential notation, and these can be in any type of unit that you want. It could be parsecs for astronomers or angstroms for circuit designers or something. You just type E to indicate powers of 10. I'll leave this set to architectural for the time being, and I will select a precision. Now, AutoCAD is actually going to record everything with the highest level of precision internally, but you might want to round off that precision just to make it a little more human-friendly. It can be very confusing to know how many 2/56 of an inch something is. So I recommend that you round it off, say to the nearest quarter inch or something, if you're doing architectural work. Angular measure can have different units. Decimal degrees is the most common. You could alternatively use degrees, minutes, seconds, or some of these other units. The way that you measure angles is controlled down here under direction. The default in AutoCAD is east is 0 degrees. So going to the right is 0 degrees. Going straight up then would be 90 degrees. So the system works in a counterclockwise fashion by default. You could change that so that north was the base angle, and then 0 degrees would be straight up. And that's typically the direction that you want for surveyor's units. I'll leave this set to east. Again, you can set the precision for the angular measure, and you can check here if you want it to go the other way so that angles are measured clockwise rather than counterclockwise. When you create blocks, you have to choose what units they're using. So here's where you can select which units you want blocks to be converted into. So because I'm using architectural units, it makes sense to leave this as inches. If I was using decimal units, I could then change this to be centimeters or millimeters. Down here, you have choices for lighting, international, American, or generic. I'll go with American, inches, and architectural. Down here on the status bar, you have the ability to add units down here as a special choice. However, it only lets you select one of these 5 systems. It doesn't give you any other choices. So I really don't recommend that you do it this way, because then you can't control the precision or the angular units or anything else. In the next video, I'll show you how to convert a drawing from one system of units to another. In this video, I'll show you how to convert a drawing from one system of units to another. We will convert from feet and inches to centimeters and back again. Go ahead and open the Architectural Imperial Units sample file from the Chapter 2 folder. Before we change anything, I'd like to measure a distance in the plan. And I need to measure something that I already know the distance of. So I could measure, let's say, this sofa here. It's probably about 8 feet long or so. Let's just verify that by using this tool, Measure. I'll click on this icon, and then I'll click near the sofa, right about here and right about here. And you can see interactively the distance there. It's actually close to 6 feet. So let's just keep that in mind. I'll press Escape to cancel out of that command. Now I'm going to change the units. So I'll type UN, enter, and change the type from architectural to decimal. And then I'll set the precision to be 0.0. Also, when you're changing units, it makes sense to change the insertion scale, but this is different than the drawing units. This is the scale that you're going to insert blocks at. And we'll learn about blocks later, but this is different than the drawing units. The units are really what you say they are in your mind. So if I say these are millimeters, then they are. If I say they are kilometers, then they are. It really depends on what you're drawing. So in this case, because it's architecture, I'm going to say that 1 unit is 1 centimeter. I'll click OK. And the units have changed, but the drawing has not. Let's go ahead and measure that again. And I'll click 2 points about here and here. And it looks like it's about 72 units. So that would be 72 inches, really, because that's 6 feet. So the drawing still has another missing piece, and that is the scale. So it's really not enough just to change the units. You also have to scale the drawing to really convert it from one system of units to the other. So to do that, I'm going to use the scale command, which is located right here on the modify panel. I'll click that icon, and now it says select objects. Just as a shortcut, I'm going to type all, A-L-L, enter. It gets everything for sure. And it still says select objects because I can keep selecting more things, but I'm just going to go ahead and press enter again to get out of that mode. Now it says specify base point. You can see that by the cursor and also down here on the command line. The base point should be at the origin point of the coordinate system, which is 0, 0, 0 in x and 0 in y. So I'll type 0, press the tab key to go over to the y coordinate and press 0 again, and then enter. Now it says specify scale factor. So here's where we have to type in the conversion factor between inches and centimeters. So I happen to remember that 2.54 centimeters equals 1 inch. So I'm just going to type in 2.54, enter. That scales everything up by 254%, if you will. Everything's bigger. I need to zoom out in order to see the whole drawing. So I'll just rotate the wheel of my mouse, and then I will drag the wheel to pan, like that. And again, I'm going to measure this sofa over here. Now it's about 180 something, so it's much bigger, and that makes sense for centimeters. It's almost 2 meters long now. So this is like a reality check I always like to do. Does it make sense? Yes, it does. Okay, it looks like I've successfully converted the units. Okay, now let's say we want to go back. We're starting with this metric drawing, and we want to go back to imperial. So again, we have to change the units to the values they were before, architectural and inches here. Okay. And now I need to scale it in reverse. So how do you do that? It's a little bit more complicated, but not much. Again, you do scale, select objects, we'll type all, enter, and then enter again to get out of select mode. And then the base point, I'll type 0, tab, 0, enter. The scale factor, this time, I don't know. I don't have a calculator to calculate 1 divided by 2.54, but I'm sitting in front of a computer that has that function built into it. So I can ask AutoCAD to figure that out for me. So to do that, I'm going to type apostrophe CAL. That means use a calculator transparently on top of this command. So I'll press enter. And now the expression is going to be 1/2.54. That means 1 divided by 2.54. That's my conversion factor. I'll press enter, and everything got smaller. Let's just go ahead and verify the size of that sofa now. I'll use the measure command again. I'll click 2 points here, and it looks like it's about 6 feet. So we did it correctly. So there you have it. The way to convert a drawing from one system of units to another involves more than the units command. You also must scale the drawing. In this video, I'll discuss some program options and their scope. To understand what I mean, let's just dive right in. Open the mechanical sample file in the Chapter 2 folder and type OP Enter for options. Go to the Display tab here. Let's change an option that has global scope. That is, an option that affects the program as a whole. I'll change the color scheme from dark to light and click OK. This option remains active no matter which drawing you're in. Go ahead and open the plumbing sample file in the Chapter 2 folder. Sure enough, the interface remains light. I can go back into Options and change that back to dark. I actually prefer dark because it gives you less eye strain. I'll click Apply. Now, some of the options have this symbol next to them, and it means the current drawing. So if I change this option, for example, Apply Solid Fill, I'll uncheck it, and that's going to be specific to the drawing. That means it has drawing scope. I'll click OK. And in this case, this particular option is visible after we regenerate the drawing database. And so we just type in RE for regen and press Enter. And when everything is regenerated or recalculated, if you will, the fill inside these plumbing objects disappears. This option is specific to this drawing. If I go over to the mechanical drawing, I can go ahead and check out the options again, and you'll see that, yes, this is selected here. So it's specific to the drawing. So you have two flavors of options, the options that affect the whole program and the ones that affect specific drawings. And you can tell them apart simply by using that icon in the options dialog box. In the next video, you'll learn about drawing templates and how you can use them to create new drawings. In this video, I'll show you how to create a template so that you can pass along drawing-specific settings into future drawings that you create. Go ahead and click New, and you're prompted to select a template file. Select the standard AUTOCAD.dwt file. T is for template. Incidentally, this folder is located deeply in the hierarchy of the user profile. I'm going to open this particular template, and that creates a new drawing, drawing 6. If we want to alter the template, we have to access it in a different way. We'll go to Open, and then choose Files of Type DWT from this drop-down. That takes us to that same folder where we can open that template file. The difference is evident here on the Drawing tab. We see ACAD DWT, and the previous one said Drawing 6. So now we know that we're actually in the template. Let's go ahead and turn off the grid and toggle off the UCS icon by going to the View tab of the ribbon. I would also like to turn off the View cube and go to the Home tab. And just so that you really understand how templates work, I'm going to create a circle right here in the middle of this space. And I'm doing that just to demonstrate this point. But you normally wouldn't create a circle in your template. This is just to show you that this information is passed on to the next drawing. Let's go ahead and save this with a unique name. So click Save As and rename this My Template.dwt. Save, and you can type in an optional description here. No grid, no UCS icon. Okay. So we've saved the template, and let's go ahead and close it. Now let's create a new drawing using the template. Click New, select My Template, and click OK. Open. Drawing 7 was created with the circle. Notice that there's no grid and no UCS icon. So basically this is the workflow for creating a template in order to pass on specific information to the new drawings that you create. Of course, we don't want to have a circle in every drawing, so we'll go ahead and erase that from the template file. Let's go ahead and open My Template, erase, type E, Enter, select the circle, and press Enter again. Save, and close. Just to test it out, we will create a new drawing, but this time, let's click the New tab, and we can access the template in an alternative way right here by expanding the Templates area, scrolling down, and choosing mytemplate.dwt. And it created a new drawing called Drawing 8 that has those specific settings set up so that now you're ready to create a new drawing. So in this video, you learned the ins and outs of templates, and you created your own template.